Hi everyone, this is Meghna. Today I am going to give a seminar in data mining and data warehousing about the topic data models in a warehouse. From the architecture point of view, there are three types of data warehouse models. The first one is the enterprise warehouse, the second one is the data mart, and the third one is the virtual warehouse. Firstly, let us discuss about enterprise warehouse model. An enterprise warehouse collects all of the information about subjects spanning the entire organization. It provides corporate-wide data integration, usually from one or more operational systems or external information providers, and is cross-functional in scope. It typically contains detailed data as well as summarized data and can range in size from a few gigabytes to hundreds of gigabytes, terabytes, or beyond. An enterprise data warehouse may be implemented on traditional mainframes, computer super servers, or parallel architecture platforms. It requires extensive business modeling and may take years to design and build. The second model is the data mart. A data mart contains a subset of corporate wide data that is of value to a specific group of users. The scope is confined to a specific selected subjects. For example, a marketing data mart may confine its subjects to customer, item, and sales. The data contained in data marts tend to be summarized. Data marts are usually implemented on low cost departmental servers that are Unix or Linux or Windows based. The implementation cycle of a data mart is more likely to be measured in weeks rather than months or years. However, it may involve complex integration in the long run of its design and planning were not enterprise wide. Depending on the source of the data, data marts can be categorized as independent or dependent. Independent data marts are sourced from data captured from one or more operational systems or external information providers or from data generated locally within a particular department or geographic area. Dependent data marts are sourced directly from enterprise data warehouse. The third one is virtual warehouse model. A virtual warehouse is a set of views over operational databases. For efficient query processing, only some of the possible summary views may be materialized. A virtual warehouse is easy to build but requires excess capacity on operational database servers. Data warehouses and OLAP tools are based on a multidimensional data model. This model views data in the form of a data cube. There are even various multidimensional models that are star schema, snowflake schema, and fact constellation. The entity relationship data model is commonly used in the design of relational databases where a database schema contains of a set of entities and the relationships between them. Such a data model is appropriate for online transaction processing. A data warehouse, however, requires a concise subject-oriented schema that facilitates online data analysis. The most popular data model of a data warehouse is a multidimensional data model which can exist in the form of a star schema, snowflake schema, or a fact constellation schema. First, let us discuss about the star schema. The most common modeling paradigm is the star schema, in which the data warehouse contains 2 points: a large central table that is called as fact table containing the bulk of the data with no redundancy, and a set of smaller attendant tables which are called as dimension tables, one for each dimension. The schema graph resembles a star burst with the dimension tables displayed in a radial pattern around the central fact table. Here's an example for the star schema of all electronic sales. Sales are considered along four dimensions, that is time, item, branch, and location. The schema contains a fact table for sales that contains keys to each of the four dimensions along with two measures, dollars sold and units sold. In the star schema, each dimension is represented by only one table and each table contains a set of attributes related to them. For example, the location dimension table contains of the attribute set location key, street, city or province, and country. This constraint may introduce some redundancy, like a country have many states and they can be entered in the location table, that creates a redundancy among the attributes province or state and country. Now coming to the snowflakes schema, it is a variant of the star schema model where some dimension tables are normalized, thereby further splitting the data into additional tables. The resulting schema graphs forms a shape similar to a snowflake. That is why it is called as a snowflake schema model. The major difference between the snowflake and star schema model is that the dimension tables of the snowflake model may be kept in normalized form to reduce redundancies. Such a table is easy to maintain and saves the storage space. The snowflake structure can reduce the effectiveness of browsing since more joins will be needed to execute a query. Consequently, the system performance may be adversely impacted. Hence, although the Snowflake schema reduces redundancy, it is not as popular as the star schema in data warehouse design. Here's an example for the Snowflake schema of all electronic sales. Here, the sales fact table is identical to that of the star schema. The main difference between the Snowflake schema and the star schema is in the definition of dimension tables. The single dimension table for item in the star schema is now normalized in the Snowflake schema, resulting in new item and supplier tables. For example, the item dimension table now contains the attributes item key, item name, brand, type, and supplier key, where supplier key is linked to the supplier dimension table containing supplier key and supplier type information. Now let us discuss about the fact constellation schema. Sophisticated applications may require multiple fact tables to share dimension tables. This kind of schema can be viewed as a collection of stars and hence it is called as a galaxy schema or fact constellation schema. Here's an example for the fact constellation schema of all electronics sales. This schema specifies two fact tables that are sales and shipping tables. The sales table definition is identical to that of the star schema. The shipping table have five dimensions or keys that are item key, time key, location key that is from location to location and shipper key, and two measures that are dollars cost and unit shipped. A fact constellation schema allows dimension tables to be shared between the fact tables. For example, the dimension tables for time, item, and location are shared between the sales and shipping fact tables. So, this is all about the data models of data warehousing, and thank you.